Hi, my name is Ralph Ramos, and my project is about predicting beach water safety from antecedent rainfall using an interactive web app. My web app is called Kaichecks, which means to check the ocean, where Kai means ocean in Hawaiian. So a little bit about me is that I graduated from Waipahu High School on Oahu. I'm currently a senior in computer science at UH Manoa, graduating in December. I enjoy creating apps to solve everyday problems outside of school and work. I enjoy going to the beach, hiking, and ice skating. What excites me about computer science is the never-ending advancement of technology. I joined SCIPE because I wanted to gain experience in data science and machine learning. I also wanted to create a solution with real-world data sets and apply my skills as a web developer. Lastly, I wanted to exercise my skills learned from my AWS Solutions Architect training. I chose this project because I wanted the community to protect themselves from getting sick at the beach. I personally have a sensitive stomach and had stomach issues after a swim. Lastly, there have been more rainy days this year, which in turn causes less days for outside activities. The problem is that rainfall runoff is one of the leading causes of unsafe beach water. The Hawaii Department of Health tests beach water at most once a week, and most of these test results could be up to 6 days old. Swimmers have no clear way of knowing if it's safe to swim with certain conditions. The bacteria known as Enterococcus causes ear infections, stomach illnesses, and skin rashes. For the data sources, I used two data sets. One data set contained the rainfall data from Hawaii Climate Data Portal. It contained CSV files from 165 Oahu rain gauges from 1990 to 2026. The second data set contained the beach water quality for 84 beach sites on Oahu from 1990 to 2024. It contains the bacterial levels of Enterococcus in CFU per 100 milliliters. I prepared the data by first merging all rainfall CSV files into a single master CSV. I then cleaned both the rainfall data and beach water quality data. I merged these data sets into one single master data set based on the beach's nearest rain gauge. Lastly, I built 7 rainfall features for the MO model. For the machine learning step, I used both the XGBoost classifier and regressor model. The XGBoost classifier model was the main model which was trained to output a risk score of a beach, determining whether it is safe or unsafe for swimming. The XGBoost regressor model was the secondary model used for predicting continuous bacteria concentrations. Both models trained on the 7 features such as rainfall accumulation over 24, 48, and 72 hours and 7 days. For my web app development, I used Next.js and Tailwind for my front end. For my backend, I built a REST API using Fast API with Python. I then used Docker to containerize my Fast API. For deployment, I used the AWS cloud. I hosted my site using Amazon Route 53. I deployed my front end using Amplify. I used an EC2 instance to run my Dockerized Fast API. Datasets and model files are stored in the S3, and ECR was used to store the Docker image. Now for the demo. My end product is a web application that contains 2 pages, the simulator and the Data Explorer. When launching the simulator, it shows the map of Oahu with a preset rainfall scenario. The island shows pins representing beaches on the island. On the left is the rainfall simulation panel, control panel, where you can adjust the rainfall intensity month and also focus on certain areas of the island. We can adjust the month to be a wet season like February or a dry season month like June, or adjust specific rainfall on specific days. On the right side, there is a beach rankings panel where it shows the top unsafe and safe beaches. There's also a data and findings panel where it shows the data results with a pie chart and additional information about the data. We can also click on a specific beach and it will show us the safety probability score. It also shows an AI summary generated using RAG to feed into GPT-4o Mini. There's also additional data information like the bacteria history and historical exceedance rate. There are three levels of beach safety, which are safe, use caution, and unsafe. Beaches with a probability score less than 25% is considered safe. Those between 25% and 50% are labeled as use caution, and those that are 50% are labeled as unsafe. The exceedance rate means how often a beach exceeds the 130 CFU safety limit. Lastly, there is a Data Explorer page that shows detailed information about the clean data and also in-depth details about the machine learning models. What I've found is that 2 in 5 dangerous beach visits would go unwarned. The 62% of unsafe days the model cannot explain confirm that rainfall is not the only driver of beach contamination. Bacteria risk peaks 1 to 2 days after rainfall. Rainfall is truly a measurable signal for beach contamination. Unsafe sample rates jumps from 4 to 21% after heavy rain. And 56 out of 84 beaches are considered unsafe on average with moderate rain in 7 days. I learned that cleaning and merging data is harder than it seems. I learned that a model is only good as what data can explain. I learned that hyperparameter tuning and feature selection are just as critical as the choice of the ML model itself. My growth this summer was about overcoming my own doubts and actually making this project possible. I went from thinking I needed more experience before starting to realizing that you just have to start building because building is the experience. A recent key takeaway quote that stuck with me is from the NBA player Victor Wembanyama. He stated that we can do impossible stuff because we don't know it's impossible. When you constantly question whether something is possible rather than deciding it isn't, you eventually make it possible. Where I'm going. After this program, I see myself continuing to learn and build with ML and data science on a deeper level. With Kaichecks, I would improve by gathering more data like tourism spikes or wastewater spills. For my career goals, I will continue on my path to become a software engineer. Special thanks to my group mates, Mana Threes, and my mentors, Victoria De La Cruz and Brian Goldberg. And lastly, Dr. Alexander Stokes for this amazing opportunity. Thank you.
Thank you very much. Very nice dashboard. I love it. And AWS, that's a tricky one to use. Are there any questions at all?
Hi, I actually have a question. How were you able to calculate like the hazard level on your web app?
So the hazard level of I use the classifier model, and so the levels are from the output of the classifier, so the exceedance rate of how much it exceeds the 130 CFU safety limit for the bacteria level.
I see. I see. Thank you.